Once again, welcome to the Introduction to Spatial Analysis with Python. Um, this graphic here kind of represents what we're going to be covering today. It's going to be a very kind of new approach to spatial thinking. I typically do not use data science as my approach in the past, so this is new to me as well. And I'm very excited to kind of have this new approach of thinking about GIS, spatial research, through the lens of data science. As you all know, that's kind of the buzzword these days in almost any kind of industry. We need to incorporate data science in many of the ways that we conduct research. And this is true in GIS as well. Let me explain a few things here. On the top left, we're going to look at coronavirus data in California directly from the LA Times. This is a screenshot from their website. On the top right here are the different kind of tools that we'll be using today, starting with Jupyter Notebooks. Pandas is a Python library. And we have Plotly, which is also a Python library for mapping, as well as charts and graphs. The bottom left here is a kind of a screen grab from Jupyter Notebooks itself. It just shows kind of an output of a data set. We'll be covering that as well. And on the bottom is a map that we hope to obtain at the end of this workshop. There's two parts to this workshop. Part one is the kind of the heart of the workshop. We'll probably spend most of our time in part one, where we'll be looking at the California coronavirus data through Jupyter Notebooks. So we're here to learn many different things, including Jupyter Notebooks. I'll kind of handhold you through a little bit of that. We're going to use Python within Jupyter Notebooks, and we're going to specifically be looking at Pandas and Plotly Express, which are modules within Python that can be used within Jupyter Notebooks. I'm actually new to Jupyter Notebooks myself, probably not even a year of experience with Jupyter Notebooks. So I'm just like you guys, learning things as we go along. Part two will be interactive web mapping. This is kind of a bonus component of this workshop, but it will we're going to build an interactive web map within Jupyter Notebooks. And we'll learn how to publish that as well. All right, so hello, Jupyter newbies, myself included. If this is the first time for you to use Jupyter Notebooks, I suspect it is for many of you. Just to let you know, Ben did a workshop on Introduction to Jupyter 2 weeks ago, and it's now available on our YouTube channel. So you can actually click on it here if you'd like to learn more about Jupyter Notebooks through his excellent workshop, which has been recorded. And there's also a help link here. I have help links all over the today's workshop, so hopefully you can follow along through these links as well. Just bring up my chat window. These slides, yes, these slides are actually available to you. Let me actually go back. If you have your if you have launched your Jupyter Hub, you should be able to see this screen here. Let me or Ben know if you have trouble getting to this screen. And you can click on the first one, Mapping LA Times. This is the one that we're on right now. And this notebook in itself is the slides that you're looking at. So the entire workshop and everything that I'm talking about, all the slides and everything I'm covering is within this notebook. So you can kind of like scroll down and go over the different things that I'm talking about. And I'm currently just at this slide over here. So hopefully you guys can be following along. You don't have to get into this kind of PowerPoint mode, but you can just kind of scroll down and follow along. And hopefully that's the best way for you to follow this workshop. Okay. Yeah. If you want to know more about this Jupyter Notebooks interface, you can click on this link here. And it has the official help link and documentation about Jupyter Hub. And you can find out more about it through this link here. But for now, I'm just going to go on with the workshop. All right. So for the most part, to follow along with the workshop, when you are within the Jupyter Notebooks interface, all you have to do is highlight a cell, which will be represented with a blue bar on the left. And when that cell is highlighted, you can hit Shift and Enter, and that will run that cell, and it will go to the next cell. So, you know, to make matters, short, you can actually Shift Enter your way to the end of this workshop. But I will be explaining the contents of each cell as we go along and go on this journey of kind of understanding kind of a situation that is happening in our community today through data and science. Let me give you a little demo about how to do kind of navigate your way through Jupyter Notebooks. These are some of the shortcuts that you will see. Shift Enter really for now is all you really need to know. But there are other shortcuts here that you can experiment with. And I just have these listed for you to play with. Here, we also have other shortcuts, which is in edit mode. And I have this cell here where you can kind of practice on. So go ahead and highlight the cell that says practice edit mode and do a Shift Enter on that cell. And it should run that cell. As you will notice, this cell is actually written in Python. And this is a kind of simple Python code. It sets up a variable and it runs a for loop. You don't have to understand the complexity of this at the moment, but essentially what it's doing, it's running a for loop 5 times and it's printing this number. So that's how you run a cell. You highlight it and you Shift Enter. The cool thing about Jupyter Notebooks is that you can change this on the fly. So I can say, instead of 2, I'm going to change this to 3 and run it again, and it recalculates and runs that cell and produces an output as well. So I'm printing the output of, mi numero at the moment and multiplied this by a range from 0 to 4 in this case, okay? Other cool things you can do in edit mode is there's multi-cursor editing, which is one of my favorites. So if you have a cursor blinking within the cell and you do a Control or Command click on another area, you can actually have this cell, the cursor blink in multiple places. So I can change, for example, a variable name that's kind of duplicated in multiple places by having multiple cursors, and run the cell again with Shift Enter, and it will run again. Okay. All right, so I'm going to move on and now get into the meat of our workshop. A spatial data science approach is what we're doing in order to map information. This is a little graphic that I found on the Carto website. And Carto is a web-based kind of cartography data science website, which I've used in the past in many different projects. And they had this graphic. If you click on this, it'll take you to their website, and there's a whole kind of introduction to what is spatial data science. It's a pretty cool resource to review. And if you look at the graphic that I kind of grabbed from Carto, this kind of paints the picture of what the direction I believe that GIS research is going towards. It's kind of, I had some people question like, where's Esri in your workshop? And Esri is actually a small part of this kind of new universe of spatial data science. And when I started GIS, all I really knew was Esri, ArcGIS, ArcMap. Those were the tools of the trade. And, we all learned GIS through Esri. So much so that many of us started to believe that GIS is Esri. which it's not. GIS is Geographic Information Systems, which encompasses so many different things. So there are different platforms. Desktop applications like Esri, QGIS is the open source equivalent of ArcMap. There's Tableau, many of us have used Tableau as platforms to do spatial analysis. But then there's this kind of versioning kind of field of open source technologies. Many of us are learning ways that we didn't have access to before through tools like R and Python. And now we can create maps and sophisticated maps and do a lot of spatial analysis through these new tools, Python and R. A little bit about spatial databases. We have SQL, PostgreSQL, different databases now support spatial layers as well. So today, we're going to be covering this kind of the Python flavor of spatial analysis. All right, so here. All right, so our workflow for today is, it's pretty typical as a methodology and workflow in any kind of data science project, whether it has GIS or not. We're going to find and acquire data. We're going to manage, clean the data, because data is never clean, at least not never the first time around. We're going to explore it. Exploration is the part I love the most, is finding the potential in the data that you have with you. We're going to model the data. We're going to kind of manipulate it a little bit and make it usable for our ultimate kind of purpose, which is to visualize and communicate with the information that we have at hand. So let's talk about our data. So, we live in unprecedented times. We all know that. So I'm taking the opportunity to look at data that's now available to us based on what is happening in the world today. My initial foray into mapping COVID-19 data was global. But when I made these kind of global maps, a lot of my colleagues asked me, well, global is fine, but I really want to know what's happening in my community. So the best resource in Los Angeles today to get coronavirus-related data is in the LA Times. And they have a page, let me go to it right here, that is updated close to hourly. And it has all the most recent statistics on pretty much everything that can be measured based on the data that they collect. Latest trends, cases by day, deaths by day. And this is an entire kind of data science project in itself. They have charts, maps, they're all interactive, and these are updated almost in real time. It's a really amazing resource, and it really kind of talks to the state of the world that we live in now, transparency of information, data being made available to the public to empower citizens to kind of make their own decisions with the data that is provided. And it also allows us to question the information that they provide, and it allows them to make their information more accurate through feedback. I have actually contacted them numerous times. The director of this agency, of this data desk, is a guy called Ben Welsh. And I communicated with him many times saying I found errors in his data. And he immediately responds and fixes things on the fly, which is very, very cool. This is the data that we'll be using today. Let's get started with that. All right, so just a quick note, their information is made available through a copyright that allows researchers like ourselves to have really free access to the information and use it for research purposes. They have their own GitHub link. So this is the LA Times GitHub link for the coronavirus data. So all their data, see how this is updated 11 hours ago, and all their information is available here. So table of contents, these are all the different data tables that they make available. and they have all the metadata, all the different fields, and what each field means. Is it a string? Is it a date? Is it an integer? And you can, at any given time, download this data and use it for your own research purposes, which is what we're going to do today. Let's talk a little bit about Python. And Python, as you all know, is a coding environment that allows us to work with data, produce visualizations, and many other things. It's a scripting language that allows us to kind of document our methods in conducting the research that enables us to understand what's going on. We're going to be using pandas and plotly today. So let's get started. This is our first actual cell that we're going to run in order to get started. And the first thing we have to do with almost any kind of Python project is we need to import libraries. And the two libraries that we're going to use today, Plotly Express, Pandas, I have links here so that you can kind of see in more detail what each one of these can do. So if I click on the help link for Plotly Express, it takes you and tells you what this library is for. This is for charting data. So we have all the different possibilities that is available to you if you import this library. And that's basically the premise of using something like Python. Is other people have built these amazing libraries that you can import with one line of code. And then you're like that much smarter. Now you know Plotly, and you can use it within your code and with the data that you import. All right, so let's run this cell. You can either highlight the cell, like I have here, and then just do a Shift-Enter. The moment you do that, you might have briefly seen a little star here. That means that the cell is running, and once it converts into a number, in this case number 5, it might be a different number for you, it indicates that the cell ran successfully. If there's an error, it will tell you below the cell that something went wrong. Number here represents the sequence of cells that you've run. So this is the 5th cell that I have run in this current iteration of my project. If I highlight it again and I run it again, that number increases to 6. It's basically an indicator of the order by which you have run the cells in your project, in your notebook. Okay. All right. So now that we have the two, the two libraries installed, we can actually use them in our code. So we're going to go directly to the LA Times and grab their data. Let me just briefly go to their website one more time, to their GitHub page, and tell you which data set we're going to be grabbing. From the many data sets that they have one that is called LA Times Place Totals. And the reason we're going to grab this data set, and it's too big to actually list here, is because, I'll show you LA Times Place Totals, because it has longitude and latitude coordinates. And for anybody who does GIS, that is like, it just makes you smile, because it makes you realize that not only is this kind of tabular data good for charting, it's good for mapping. So this is, I think, one of the few data sets within the LA Times data desk that actually has XY coordinates, latitude, longitude coordinates. So this is the one that we're going to be using. Okay, so here's the cell that says read CSV. We're using the Pandas library to actually bring in the data and putting it in a variable that I just happen to name LA Times, lowercase single word. And then we're bringing in this data set. Do a Shift-Enter on this, and if you have a number there indicating that it was successfully done, it means that the data is now within your notebook. How do you know what this data looks like? now that I put it in a variable called LA times, you can just run another cell that just names the data set LA times, and shift enter and run it, and it will output a preview of what this data looks like. So LA times on itself will show me the first 5 records and the last 5 records. It also tells me that I have 82,000 rows. That's a lot of data in 8 columns. But let me show you a few other commands that you can have here. So we have LA times shows you a preview. You can also use dot head on the variable that has the data. So I can type in LA times dot head, open paren, close paren. And if I run this cell, it shows me the first 5 records. I can add a number in here, and I can say, show me the first 10 records. Run this again, and it shows me the first 10 records. So I hope you're starting to see a kind of a trend here on how Jupyter Notebooks works, where you can run something, change something, and run it again. And kind of this is part of the exploration process I talked about. Here, we're starting to explore the information that's made available to us through these cells. Okay, let's try that on our own. Let's try a new command to find out the shape of our data set. And you'll know what I mean by shape if you actually try it out. So type in the cell LA times, which is the name of our data set, and dot shape. And note that the dot shape command does not need parentheses. So I can just run this as is, LA times dot shape, shift enter, and it produces an output. And it tells me that I have 82,880 records. Just a few days ago, it was under 80,000 records, and 8 columns. So this is rows and columns. Okay, let's try something else. I want to know, okay, so I know 8 columns exist. I want to know what the columns are. So if you, once again, type in LA times and dot columns, this should, oops, I forgot shift enter, should output a list of the names of the columns that we have here. So date, the name of the county, a FIPS code. This is an identifier, a geographic identifier for the county. The place name. So this is like, you know, Westwood, Culver City, Boyle Heights, that's place. And the number of confirmed cases. And then we have a note and an X and a Y. All right. Are we all good so far? Okay. We're going to go now into cleaning the data. This is many people's least favorite part, because we all live in this fantasy where data is perfect and it allows us to immediately start working with it. Let me tell you, this is never the case. Data is never perfect. It's never clean. So you will almost certainly have to clean the data. You have to budget so much of your time to this phase here, which is exploring the data, finding what's wrong with it, and then finding ways to clean it so that you can do what you want to do. When we look at our data, the 8 columns that I just outputted, there are immediately things that you might think, what if? What if there are empty values for confirmed cases? What if there are no coordinates? What if, you know, other factors? You got to start asking what if questions. And then we need to address those. The ones that I came up with also through exploration, trial and error, is that there might be null confirmed cases. We might have empty coordinates. We might have incorrect coordinates. And this is something I found out after I looked at the data. But thinking about, you know, the X, which is the longitude coordinates, we can't have positive longitudes in California. I'll explain this in a little bit. And we can't have null dates if we're going to chart information by date. Okay. All right. So in order to clean up our data, we're going to be using a dot query method. And I have a link here to the help on how to use .query. But essentially, it allows us to add kind of SQL language within Python to query the data. So if you're familiar with SQL, it's great because you can actually write SQL code within the argument and filter the information. So first, let's see if there are any records that have null values for confirmed cases. And null, or NaN, is spelled in this way: capital N, lower a, and capital N. So the LA Times dot query in a parentheses, and then your SQL statement within double quotes. If I run this, it actually tells me that there are no null confirmed cases. So this is just confirmation, because in the past, there used to be null confirmed cases, but the LA Times has fixed those issues, and now there's not a single row with no confirmed cases. And there shouldn't be in this data set, if you think about it. What about the null values for X? And X is our our longitude coordinate. So if we're going to map this information, we can't have rows that have null X coordinates. So let me run this. And okay, so this does present problems, and it had a result set here. 2,302 rows in our data set does not have an X coordinate. So we're going to have to deal with that. If I move forward, I want you to try to find out if there are any null Y coordinates in the data set. So you're going to type in LA Times, and we're going to query the LA Times. Remember, it's an open paren. It's a double quote, and we're going to try to see if Y, and the syntax for the dot query for equals is double equal signs, not a single equal sign, but double equal signs. And since we started on the outside with double quotes, we have to put the NaN, which stands for null, in single quotes. So a little bit getting used to the syntax here, but once you get the hang of it, I think you'll understand. The outside, I started with a double quote. So if anything inside needs quotations, it can't be a double quote. So we're going to use single quotes within the SQL query. Okay, so I'm going to run this, and sure enough, there are equal number of null Y rows as there were X rows. So we have 2,302 rows with null values for the Y. And if you look at why this is, it kind of makes sense. A lot of these are neighborhoods that are don't have actually coordinates or homeless counts that are not kind of singular in position. Okay, let's continue this process of cleaning our data. What about positive longitude coordinates? If I run this cell, it actually produces results. San Mateo County, Pacifica, has a positive longitude coordinate 122 and a negative, and latitude coordinate is 37. So where is San Mateo? Let me see here. Okay. So if we go to Google Maps and I type in San Mateo, okay, and we go to San Mateo, you'll notice that the coordinates for San Mateo is 37.5, negative 122.3. So if I go back to my results here, it's positive 122 and 37. So this is an error actually on the LA Times side. And I've actually written Ben to tell them that this should be fixed. So this is good that we can query this out of our data set. And finally, are there any null dates? So if I run this, there thankfully, are no null dates. So what does this tell us? We have to then filter out the data that is problematic in order to advance in our project here. So I've combined all the queries into one statement and redefining LA times so that it only contains data that we want. So LA times.query, where confirmed cases is not null. Notice it's not two equal signs. It's a not null operator here. So I want all records that have confirmed cases. I want all records where X is less than 0. So it eliminates San Mateo bad data. I want all records where X is not equal to null and date is not null. All that in one nice statement here. And once I run this, this is what the data looks like, okay? If I do a head. And what I'd like you to do now is to tell me or find out on your own, how many records do we have now? Now that we've filtered this data, how many records do we have now? So let me pause and let you ponder on that for a second. And let me ask Ben if we have any issues that I should address. How are we doing, Ben?
We're doing well. There are no issues, but there is one question. Why do you have to include Python as the engine in these commands?
To be honest, I put it in there because it didn't work without it sometimes. Maybe Ben, do you have an idea why that would be?
I suspect it has to do with the specifics of the query function acting on this. The Python will require potentially working with the series object. I think the LA times is a data frame, a pandas data frame. So potentially it just has to do with reading in the data correctly to query it, but I'm not sure.
Yeah. Thanks. And Ellen, very good. Let me, yep. So if I run a shape on my new data set here, yep, I have the same results as Ellen, 80,561. How does this compare with records prior to cleanup? If I go back to when I did the shape prior to this, let's see, I think it's right here. So we started with 82,880 records. So we have, yeah, Akshay, something in that neighborhood, like 2,000 records have been filtered out. And those are the records that we actually don't want in order to move forward, because they will cause errors down the road if we kept them in there. Okay. All right, so our next exercise is to find the most recent date in our database that we have. So since our data has 80,000 records, it's too large. So what I want to do here is actually create subsets of our data that are more workable, especially for this workshop, because the more records you have, the more computer intensive it is, and the longer it takes for things to render. So let's create subsets of data. One of them I'd like to do is to find data by the most recent date. So what is the most recent date? We can find out simply by, outputting LA times and looking at the results, like so. And we can guess that the LA times did a good job and sorted the data the right way, and the most recent row is the most recent data. But that's a lot of guesswork. I want to be accurate here so that if I were to run this notebook in the future, I have that most recent date no matter when I run this notebook. In order to do that, let's sort our data set by using an argument called sort values. And this is the syntax for it, LA times dot. We're now getting familiar with a dot and then a command. We're going to sort the LA times data set by what? So in the parentheses, we have to specify what column we want to sort it by and whether we want it to be ascending. So in this case, I'm redefining the LA times data set sorted by date ascending. When I run this, it runs successfully. I don't see any error messages. And we can actually output the tail end of this instead of the head. So we're going to use LA times.tail instead of heads to find the last 5 records in our data set. And sure enough, 2020, July 20th, that's yesterday, is our last data set. But we need to put that date in a variable. So how do we do that? We're going to use a method called iloc, index location, and there's a link to the help if you wanted to go to the official documentation about that. And iloc is a widely used kind of method to find certain rows in your data. So to get the value of the first row in a data set, you can do .iloc with a paren 0 and then the column name. To get a value from the last row of the data set, .iloc -1, and then the name of the column. So see if you can figure out how to grab that last date. So if I type in LA times .iloc and do an open paren and do a 0, well, if I do a 0 and leave it at that, it actually outputs all the values in the first row of my data set, because I didn't specify a specific column. So it gives me everything in that first row: date, county, FIPS, place, confirmed cases, etc. I can be more specific and I can say, oh, but I want the date. So I put in the date in single quotes or double quotes, it doesn't matter. And I hit enter, shift enter, and it gives me just that column in the first row. So 2020, March 16th is the first date in our data set. And if I change this to a -1, it allows me to find the last date in our data set, which is July 20th. So thinking about this, if I ran this notebook next week, most likely the first row in the data set won't change. But the last row in the data set is most likely to change because data is updated regularly. Okay, so let's put this information, the last date, let's put it in a variable, and we're just going to call it last date. So LA times.index location, iloc -1 to get the last row, and a specific column specified in the square brackets to get the last date. I run this because I'm outputting last date, and it tells me that last date is now July 20th. All right. What is the meaning of all this, of doing all of that? Now that we have last date, and now that we have defined it into a variable, we can use it in a query. And that's the beauty of coding, of Python, any coding language, is putting things in a variable so that you can use that variable in the code later on. So we have last date, and we can use it within the query code. So if I wanted to have a subset of my data set that's just for a single day, in other words, just yesterday's data, and eliminate everything else. So let's create a new variable that will hold data, LA times _ single _ day. And then the query for it, if you notice here, it says LA times.query, and it's the same syntax, date, double equal signs, but instead of hard coding something in, I have an @ sign, which indicates it's a variable and last date. This is how you include a variable within a query, is by adding the @ sign. Okay, and then if I output this, this is what data looks like. And now instead of 82,000 records, we're working with 772 records, which is a lot more manageable. for us. Okay. All right. So now create a variable for LA times underscore LA that is a filter for just LA County data. So we're going to create another subset of our data, which is just Los Angeles data. So it's LA times underscore LA is what I chose to name it. And it's going to query our larger LA times. This is the one that has 82,000 records, dot query, where the county, double equal signs, is Los Angeles. And if I run this, it tells me that it created that data set. And before I move on, I want to actually output this to show you what it looks like. So if I just output LA times underscore LA, it shows me that the LA data set has 35,000 rows. That's pretty big, but it includes all the data just for Los Angeles and all the places in Los Angeles. All right, so now we have 3 data sets to work with. The LA Times, which is 82,000 records, LA Times single day, which I think was 700 or so records, and LA Times underscore LA, which is just LA County data. That one had 30-something thousand records. Okay. So those are the 3 data sets that we're gonna be working with moving forward. So, you know, before we get into the stats, just to kind of review, in the last, 40 minutes, we've done quite a lot. We've gone to the LA Times, we've grabbed, a close to real-time data set from directly from the LA Times GitHub page. We've explored the information that's provided, and we've cleaned it up, and we've created subsets of the data. So that's a lot of work that we've done in a short amount of time. All right, so let's kind of do a little bit more exploration of the data that we have at hand. We can output some very quick statistics. So for example, there's a method called describe. If you type in LA Times and the field name that you want to get some statistics on, and then dot describe, so you're chaining commands here, starting with the data set, the column, and then a dot describe. It outputs a series of statistics about that field. So it actually looks through the entire data set and does statistics calculations on that field. So for confirmed cases, all 80,000 plus records, the mean is 149 confirmed cases across the entire data set. We have the median here at 50 percentile here is 37. Okay. You can describe in different ways too, and I found this to be very informative. If we group the data before we run describe, it allows us to do something very, very cool. So if we group the data by county before we run describe, now it's going to describe at the county level. So when I run this, for every distinct county, so now we have Alameda and so forth, Los Angeles, Long Beach, Orange County, it outputs specific statistics for each grouped row. So we know, and this is currently, I think it looks like it's in alphabetical order. So we can actually change the sort order. So now we're combining all the different things that we've learned so far. Data set, grouping by, so we're grouping by county. What field are we describing? Confirmed cases. Describe it, sort it. Okay, so we're sorting it by max. Why max? Because if I go back and see the output here, these column headers are what you can actually sort by. So I can sort by the maximum number, and I can output this information, and now it's sorted by the farthest right column. So now we know that for any single row, the max value is in San Diego. So there is also an LA is a close second. Okay. All right. So instead of grouping by county, since we live in Los Angeles, and we've created a subset of our data that is LA times underscore LA. Remember, this is the 30,000 plus record data subset of the data. We can group by places, and places are neighborhoods. Like I mentioned, Westwood, Culver City, Santa Monica, those are what they define as places in Los Angeles. So why don't we group by, instead of county, because we're on a single county now, we'll group by place. And we'll look at the confirmed cases, we will describe it, and we'll sort it in the same way we did the counties earlier. And when I run this, and since there's so many places, I'm only outputting, if you notice here, the dot head in the end, the top 50. And this outputs the same kind of statistics, but within LA County. So within LA County, where are the hot spots for the coronavirus? And this is the result: Long Beach, East LA, Southgate, Pomona, Boyle Heights, Downey, and so forth. Okay. All right, any questions so far before we begin to visualize this data? So let me pause for a second here. Yeah, so Ben is answering some of these questions. Does the order of these commands matter? It certainly does. It's chained in the order, and it runs in the order that you put it in. Is there a rule to follow for the order? I mean, yes, you define what that rule is, but it's, you know, you kind of always have to start with a data set in order to do something with the data set. And then in this case, we have to group it first so that it then creates a grouping of that data set. And then we describe it based on the field name. So in essence, none of this order can change if we want to produce the same results here. In the query command, why do we need to put the whole condition within a double quotes? Oh, I see. That's a good question. I actually haven't tried it with without the double quotes. My guess is that it won't run, but it may. So actually, I'm not sure. I'm mostly basing my approach based on the documentation. I don't know if that will work or not. How do we determine what needs to be cleaned? Okay, the guideline for that is, you know what needs to be cleaned when something doesn't work. So when you are attempting, you know, for the first time, you get a data set and you're like, oh, I'm going to chart this. And then you run into an error. A bar graph doesn't produce. A map has an error. And then you investigate further and you realize, oh, there's an error because I have missing data. There's an error because there's text within a column that should all be integers. Those kinds of things become, you know, relevant as you move forward and trying to do your, advance your research, and you have to go back and find what those errors are. I've already done this exercise of working with this data set for so long that I found so many errors in it, and I've gone back and forth with the LA Times and they fixed it, but still errors. This is human data. There's always going to be errors and you need to fix it for the most part to move forward. Why do we use confirmed cases and not a column like count? Count is part of the statistical description of the data, and confirmed cases is a row by row single number of confirmed cases by place and day. So you can use count for, if you wanted to have a count per place or county, confirmed cases if you wanted to actually see the number of cases per day per place. So those are kind of two different things. Okay. Why is the LA mean smaller than the East LA mean? Los Angeles mean. I haven't looked at that. My guess would be that the definition of LA, if that is the case, I haven't looked at that, is actually a specific neighborhood within Los Angeles rather than the larger Los Angeles metropolitan area. That would be my guess. It could mean downtown LA or kind of a smaller subset of LA. All right, so let's do some fun stuff now. We've cleaned up the data, and now let's start to visualize some of this data. We're going to use Plotly, so we're going to bring in Plotly Express. There's help item here about what Plotly Express can do. Kind of went over it here, scatter plots. They have all kinds of different plots here, bar charts, and you know, bubble charts and so forth. So we're going to go over a handful of these in the next few minutes. Okay. So now we have the original data set, which was LA Times placetotals.csv, which is directly from the LA Times GitHub page by place. And places are units of neighborhoods. So let's create a bar chart to get things started. So for example, if we wanted, and I'm creating a new subset here, and I'm titling it West LA, although maybe it should be Westwood, but I'm titling it West LA. And I'm querying our database to only include where place is equal to Westwood. Remember Westwood, everyone? It was like a long time since I was there. But let's bring in Westwood in our query. And I'll explain why this is in square brackets in the next slide. And we're going to plot it using Plotly Express. So we're going to say our shortcut for Plotly Express is px, Plotly Express dot bar. So this is defining, hey, let's create a bar graph and parentheses and then arguments within the parentheses. We're putting West LA in there, which is, again, a subset of our data. It's just place is Westwood. In the x-axis, we're putting the date. So x-axis is going to be the date. On the y-axis is going to be a measure of confirmed cases. All right, so when I run this, it produces our bar graph. So there we go. March all the way to July 20th. You will immediately notice what's happening here, which immediately prompted me to send an email to the LA Times. I do this a lot, and say, hey guys, what's going on? Why are you missing data? Apparently, data did not come in on the July 4th holiday. So this is legitimate missing data that they were not able to collect on 3 days that surrounded the July 4th holiday. So there's a gap in our data. And this is something that exists, and we have to live with what we have. They can't produce data that they don't have. Okay. So moving forward with this bar chart, let's do a little bit something fancier. So instead of just Westwood, what if we define West LA to include multiple neighborhoods? So Westwood, Santa Monica, Culver City, all in a list within the query. Okay, so place is equal to a list, which is indicated by the square brackets, comma separated values. You can add as many as you want. Note, however, you cannot misspell. It's case sensitive. It has to be exactly the way the city is spelled and listed in the data set. Okay, So in this case, I have 3 places or neighborhoods: Westwood, Santa Monica, Culver City. I redefine West LA to be 3 neighborhoods. I do the exact same bar chart. And when I run this, I see a similar graph, but when I hover over this data, within a single bar, there are these divisions. They're like stacked bars. What are those stacked bars? So I'm going to move forward. We can use colors to represent different neighborhoods in our stacked chart. So just by adding another argument or color, and I say, what do I want color to be? I want it to be the place. And when I run this, it now differentiates each division within the stacked bar chart to be a color, and a distinct color that represents the place. And conveniently, it also adds a legend for us. So now I have Westwood in green, Santa Monica in orange, red, and this Culver City in blue. So that's a much more informative graph there. Moving forward, I can also, and this is, you're starting to realize all the kind of fun things that you can continue to explore and use in different ways to visualize the same information. I'm adding something called facets. Rather than in a single stack chart, we can use facets. And by adding place as an argument within facet row, if I run this now, it separates out each place into its own chart. So now we have 3 separate charts where we can kind of compare what's going on within each place or neighborhood. Okay. All right, but I digress. We're here to map this data and not create bar charts. But this whole process to me is very important for me to, before I even start to think spatially, to really, really dig in and understand the data that I'm working with. You kind of have to really feel the information that you're working with and try not to do something you can't do with what you have in hand. So scatter plots is what we're going to do next. The documentation help is there. The scatter plot is similar to the bar charts. The kind of structure of how we string together the code to produce a scatter chart is very similar. So I'm going to just skip over here to produce this scatter chart. So similar to the bar chart, let's do a single day. So remember, LA Times single day, we define this by querying what was the last date in our data set, which was July 20th, and creating a subset of the data for only July 20th data. That's the LA Times single day data set. In the X, we're going to use the X, and then in the Y, we're going to use the Y, the latitude and longitude coordinates. And I'm just adding a hover name, which is an argument that allows you to, when you hover over the points in the scatter, it lets me know what place that point represents. That's what this does. So when I run this, it produces this output. Now, what does this look like? It looks like a map, doesn't it? Well, at least to me, it kind of does. The X here, these numbers here represent longitude coordinates. The Y here, these numbers here represent latitude coordinates. When the Y hits 0, all the way down in the bottom, that's our equator, okay? And when the X hits 0, that's Greenwich, the line. So 0, 0 would be somewhere off the coast of Africa. So here, we're almost kind of producing our own Cartesian coordinate system here, just based on a scatter plot with X's and Y's based on latitude and longitude coordinates. Exactly, California, thank you. This is the shape of California. LA is down here. This cluster here is Los Angeles. This is the Bay Area over here. We have a cluster here for San Diego, and so forth. And the hover over allows us to see what each one of these are. This is pretty cool, but is this informative? Probably not. I can't even tell the number of cases that's happening in each dot. So what can we do to improve this information, this visualization? So moving forward, color. We can use color to color code the dots. So there's an argument within scatter for color. And if we add a kind of a numeric data type to color, confirmed cases in this case, it's going to color code based on the measure of confirmed cases. So when I run this, now we have a little more information. We have a scale here, from dark blue to bright yellow, and these are color coded accordingly. It's predominantly dark blue, but there are some hints of areas that have lighter colors, which in this case represents higher number of cases. There's different things you can do with a Plotly output. You can actually click and drag and zoom in to particular locations. You can hit the home button here to reset and then go back in and zoom into different areas. However, the color didn't really, it marginally improved our visualization, but I think we can do better. So we're going to use size as another measure to visualize our data. So we've done color, and now we're going to use size. There's two arguments here I want us to use: size, and to define how we want to size it. We want to size it by confirmed cases. And we want to set the maximum size in pixels. So it's 40 pixels diameter of the circle is going to be the largest circle for confirmed cases. And I also took the liberty to add a title to our chart. So let's see what this looks like. So now we have a title, confirmed cases for July 20th. Now this looks a lot more informative, doesn't it? Instead of single-sized dots and dots kind of clustered together, not able to see each other, now we see differentially sized dots that represent confirmed cases. The larger the dot, the higher number of confirmed cases. So now this chart is really starting to pop out at you. Different areas are showing more information to the eye and lets us understand this data in ways that we didn't before. And I can also zoom in to different areas. I can hover over and look at different trends within a particular area of the chart. Okay. All right, so let's think about the scale that we're working at now. Right now, I'm using the default colors. You can actually define what colors you want. So I have a link here that shows you all the built-in Plotly color scales. And if I scroll down, these are the names of the colors. And there's actually a nice kind of chart down here that shows you different sequential colors, diverging colors, categorical colors, and so forth. And the name that's written on the side here, this is what you would type in your code if you wanted to use that scale. The one that I am going to use is one of these. Forgot which one it is. Maybe it was red to green for a diverging color set. So we can kind of define what we want to be red on one end and green on the other end. So if I go back to my code, you can actually, with this argument for color continuous scale, define a new color scheme. I have red, yellow, green. Notice too, I have an underscore R here, which reverses the color scheme. So if I don't reverse it, the lower end will be red and the higher end will be green. I want it to be the opposite. I want higher number of cases to be indicated by red and lower numbers to be indicated by green. And so I need the underscore R to reverse the color scheme. Now when I run this, I have a new color scheme. Green represents lower numbers and red represent higher numbers. All right. So one thing I noticed here when I look back at this kind of scatter plot here is that a lot of this information skews green. That is because there's a larger number of records on the bottom end of confirmed cases. And yet the scale is equally distributed. So how can we address this issue? So if we look at this, we can define a range for our scale from the bottom to the top. How do we want to define the range? We can actually do it mathematically. So let's try to make it kind of relevant with the data that we have. So range color, which I'll get to next in the next slide, before we define the range, let's find out what the mean is for our confirmed cases. So LA times single day is the data set that we're working with. I want to find the mean for confirmed cases, which is what we're mapping here. So by doing a mean in parentheses gives me the mean. I'll put it in a new variable, LA times single day mean, and I'm going to output the mean for our data set, which is 396. Okay. It's interesting. This has gone up from yesterday, which I guess makes sense with the recent numbers being pretty high. Okay, so close to 400 confirmed cases per day, I'm sorry, per place is the mean for our data yesterday. Okay, now that we know the mean, we're going to define range color, which is the color range for our scale. The bottom is 0, so 0 is going to be green, and the hottest red is going to be twice the mean. Why twice the mean? Because this is a divergent scale, so we want the mean to be smack in the middle of that color scale. And that's why I double the mean. Hope that makes sense. So that way, double the mean becomes the the reddest area. Okay. So when I run this, this shows that this paints a completely different picture now, because the scale has changed. Anything above double the mean is going to be the brightest of red. The yellow means that this location is the mean. So areas that are yellow represent areas that are average. And then green areas are below average and red areas are above average. Okay. So the animated, oh, okay. So before I move on, I wonder if there are any questions. And I noticed there's a gardener in a house next door, so I apologize for the noise. Ben, are there any things?
There were two questions from a little bit ago. One is, what is the point of lasso select?
I'm sorry, what is the point of what?
Of lasso select.
A lasso select. A lasso, oh, within the output. Mm-hmm. The lasso select. My guess here, okay, is that you can chain, or you can actually have side-by-side visualizations like graphics. You can have one chart informing another chart. And the lasso allows you to select a subset of one chart to then modify the results on the other chart. But I actually haven't really used the lasso myself. So I've just seen other people use it in that way. So I hope that helps. Anything else, Ben?
There was a question, could you specify a Jenks break or equal count in the visualization?
Can I specify what again?
Or maybe you want to specify, Alexander, in the chat, a Jenks break?
Oh, could you specify Jenks break? You would have to calculate that yourself. Jenks natural break, there is a mathematical equation for that. So you have to actually do the calculations within your own code, find the breakpoints where they are, and then define them in order to map the information the way you want to. So Plotly Express in itself does not have the ability to just, for example, unfortunately, just say, I wanted Jenks. I want equal interval. So you actually have to build those calculations in yourself. But yes, it is possible. And there may be other libraries out there that allow you to do that, but not within Plotly Express. All right. Are we good to go? Move forward. Let's see here. Doing okay. So moving forward, this is just kind of a bonus but very cool visualization that you can do. It's an animated scatter. And I'm going to build this in the same way that we worked previously. And let's work with our LA Times LA data set. So this is just looking at LA County data. And so this is starting in March for all LA places. Get the mean like we did earlier for a single day. So what is the mean for LA County data? And that's 168 is the mean, just in Los Angeles. And then we're going to build a scatter plot of this information similar to what we did earlier, except now we're only doing LA times instead of single day. And we're adding a new argument here for animation, and we're making it be the date. This wouldn't work with our previous data set, which was single day, because it only has a single date. But if we work in LA County and all the places in LA from March till yesterday and make an animation frame for date, and if I run this, it'll create a frame for every day that exists in the data set. And I can actually move, it starts on March 16th, and there's really nothing to see there. And if I move this and drag it to the right, the data grows as the date comes closer to today. So you can actually navigate through time and see how different places are lighting up, and maybe some are not, based on dragging this left and right. You can also play it. There's a nice play button here that, oh, okay, the play button doesn't work. I think Ben mentioned this last night. But you can drag this left and right. I think I know why that play button doesn't work. There's another argument that you can feed to kind of make sure those dots stay in place. But it's not there at the moment. But you can play this by moving this left and right. Okay. Now, what's interesting here, since we defined the midpoint, the yellow, to be the mean, is that everything starts out below the mean. So it's all predominantly green, but as we move forward, everything starts to creep over the mean. And areas that are still in green are areas that have that have not had surges in the virus in those areas, because they're still below the mean. Okay. All right, so let's put this information on a map. Plotly Express actually has its own kind of mapping features other than the scatter plot that we've been using. And this is primarily to produce quick and easy maps. They have a scatter_geo argument in order to do that. Then here are examples of what you can do with the Plotly Express library to produce maps. So you can do US wide maps. A lot of agencies use this to produce county level maps as well, and so forth. Okay, so we're going to use this scatter geo to produce some maps. essentially, it's exactly the same thing as the scatter plot, except that now we have a underscore geo argument here. So here's our latitude, longitude, confirmed cases, the hover name, the size, continuous color scale, and so forth. I'm adding a new argument here, which fits all the locations within the bounds of our data. And this is the argument for that, which says, hey, update the geography, fit the bounds to the location of our data. And when I run this, you will see that now we have the dots in reference to a map. So here's California, and you can see our dots on the map. Moving forward, I can also do this for LA. So instead of LA, what was our previous one? It was single day for California. Now we're gonna do it just for the LA Times, LA data. And when I run this cell, it'll produce a map that is more local because it now produces data in LA. And I've also added the animation frame. So within the map, we can actually move this left and right to produce the same graphic, but in the context of a map. Okay. All right. So this kind of concludes the first part of the workshop. And once again, I apologize for the noise in the background. Let's pause for a second. I'm here to answer questions before we go on to our second part of the workshop, which is building an interactive web map and learning how to plot this information on a leaflet map and then publishing it on a website. So that's going to be the part 2 of the workshop. Let's take a 10-minute break. So let's get back at 10:40. And the second part should take maybe 20 minutes or so. So you're welcome to hang around if you'd like. And I'm here to answer questions as well as Ben. Ben, what's going on?
So there's a question, is it possible to change the map projection in geoscatter?
Is there yes, there is actually. So let me see. So if you look at the documentation here, let's see. Oops. Oh, there we go. Okay. Let me see. Here's the reference. And I think there's an argument that you can add for, wow, this is a huge, let's see. So these are the arguments that you can add for projection, Mercator, and so forth. Okay. I think also another helpful tip might be when you want to know more about a particular argument, let me see if I get this right. I can type in help within my notebook and type in the method that you want help on, and it will tell you what you can do with that argument. So hopefully, and these are all the different things that you can feed into within the parentheses. Lat long, location, color, we've covered a lot of these, hover name, but there's so much more that you can do. We covered animation frame, colors, range colors, what we worked on earlier. We work with size, and here's a projection. So you can add a projection to change the projection, and so forth. All right. Sarah, the break is happening right now. I'm just answering questions. We'll be back at 10:40 for the second part of the workshop, which should take 20, maybe 30 minutes. We might go 10 minutes over, maybe, and maybe not. Oh, I'm okay. Thank you, Sarah. I'll just stick around. Why does it matter to pay attention to projections? That's a really good question. In terms of visualizations, there are projections that kind of cater to different areas of the planet. So Mercator is one of those projections that is global. It kind of flattens the Earth in a way that the North and South poles are kind of extended, so it's a straight line instead of a curve. But because the Mercator projection does that, it allows you to circle the globe and have the same kind of look and feel no matter where you're on the planet, unless you are doing polar research.
Yeah,
If you're doing polar research, as well. And then there are polar projections for that. Different areas, there's for example, Albers, USA. That caters for USA research, but it doesn't necessarily work well if you're just doing Los Angeles. If you're in LA and you're working with LA data, you want to work with local projection coordinate systems like State Plane, California. I think it's Zone 10 or something, or a UTM coordinate system that is specific to your area. UTM coordinate systems are available for angular areas all over the planet. So you need to find out what zone you're in and which UTM coordinate system to use. Not all of this is supported in Plotly Express, but it definitely is if you take this out of Plotly and use GeoPandas or other libraries that are more kind of sophisticated, or you bring it into ARC or QGIS, then you'll need to really work with projections. Is there something else I missed, Ben? Is there other questions further up I can answer?
So there was a question, what does the method update geos do?
I'm sorry, does the method?
The update _ GEOS. When you call the function on Fig, what does that method do?
Update GEOS. I actually don't know. Is that one of the arguments?
Yeah, so if you scroll down the notebook.
Oh, okay.
Right there.
I'm sorry. Yes, thank you for that question. Yeah, I just kind of glossed over this. If I don't put this in, so if I comment this out and I run this, well, I did. Wait, hold on a second. Let me try that on this one. Hold on. Oh, okay. So something is happening. It's not opening the map for me. Essentially what that does, the update geos, and then the argument within it says to fit bounds. Plotly Express isn't really meant for local data. So it doesn't have a good base layer for Los Angeles, for example. So if you don't put that in, it's gonna kind of show you the entire United States, and your data is gonna be on the left side of United States. So the update geos fit bounds tells it to zoom in to the extent of the data that we have. So that's just kind of a nice line of code to add so that you don't have the user zooming in to where the data is. So it just zooms into the extent of your data. Okay, let's see.
Another question was just about more information for the scope argument within scattered geo.
Scope argument. Oh, right. So scope, and again, there are defined scopes within Scatter Geo. So let me show you what they provide. So in some ways, you're at the whim of the tool that you're using. So sometimes this tool will work for your research and sometimes it won't. So this is kind of a decision you have to make whether you want to use this library or not. I like to start off with this library because it's easy to use, it's quick, and it's efficient to get started with. But it may not be what I eventually end up using. The scope argument allows us to default the map in different areas of the world. So I can say the scope be world, USA, Europe, Asia, and so forth. But these are the only areas that Plotly Express kind of makes available to you. Okay. The next part of the workshop, I'll be using Leaflet, which doesn't care about scope. There's data all over the world with Leaflet. So this will become irrelevant in the next days. How can you take data not found on GitHub and import it? Yeah, that's a really good question. This particular data set imports the data with that one line of code directly from GitHub. Let me just show you where that line of code is, right? The read CSV. This is a URL, which means that the data exists on the web. But you know, this can be a local CSV as well. So if you find data, you put it in an Excel spreadsheet, you save it locally, you can actually then reference it locally. So for example, this here can be, you know, within data/mydata.csv. So this way you can bring in any CSV and then work with a CSV within your notebook. Okay, thanks, Kian. I came across this book titled How to Lie with Maps, exactly. Do you have resources to recommend best for best smart mapping practices? You know, this is a lot about your conscience, right? It is so true. It's not just maps, you can lie with data. So this is really, there's a whole ethics about information science. What do they say? Power, you are empowered by the tools that you have, and that in kind of use that power wisely. You can manipulate, like we did in this workshop, just by changing the range of the data. You can change the map to show more red or more green, depending on what story you want to tell with your data. And that is entirely up to you, and the responsibility of you as a, you know, a conveyor of information to the public to use that power wisely. You know, so I don't know if I have any resources to recommend from that other than be wise about how you go about what you produce. Okay. Right. I wonder if there are any questions I missed. Feel free to type it in the chat if there's something else. Instead of filtering out the positive x coordinates, could we have applied a function to make them negative? Yes, that's probably even better, right, Alex? And that's probably the right thing to do because we investigated this data. We went to a secondary source to confirm that the only error was that they forgot to put a negative there. So we can actually go back to our code. And that's the beauty of this notebook, is instead of filtering it out, you can actually do what you recommend here, which is update the data by changing the coordinates to be negative for the x values. That's a great suggestion. And that's something that you can build into this entire process. For the fit bound parameter of the update geos, what are the possible key values? For example, you assign locations. That's a good question. I don't know off the top of my head. I'd have to look that one up. I just know that locations is a kind of a catch-all for to define what locations are being used in the current visualization. So I don't know off the top of my head, but there might be other options. You're right. There always are other options. All right, any other questions? In a minute, I'll dive into our second part, which I guarantee is gonna be quicker. Ben, are we good, you think?
Yeah, I think we're good to go.
All right, awesome. Okay, so let's go back to, I think if you go back to this page in your Jupyter Hub home, it should be typically, let me see, a different tab where it shows you what files you have in your Jupyter Hub. And go to the second notebook, which is marked by 2. And launch that notebook. And let's work with our second part now, okay? So I'm gonna go in slide mode, but you can stay in notebook mode right here. And now we're gonna work in building interactive web maps with data that we've been using. So it's kind of a different flavor of mapping. We used something called Plotly previously. Now we're going to use a library called Folium, which is specifically for web mapping. Yeah, so the libraries we're going to use, Folium. I'll show you Altair, which is a charting library as well, but only very briefly, just to kind of make a point in the end. But primarily, we're going to be using Folium for this workshop. Here's some resources for Folium and different kind of examples that I found to be at least useful in terms of putting this workshop together. The official documentation, let me visit that. Python data, leaflet maps. Leaflet is an open source web mapping library. It's a JavaScript library. I've used Leaflet a lot, and I love Leaflet because it's open source. There's a strong community behind it. If you want to publicize your research or information on the web to be interactive through a map-based interface, Leaflet is a great resource to have. It doesn't cost anything. There's no subscription model. There are APIs available, and there's a robust community behind it. So I highly recommend Leaflet. Other options that you could go with are like Google Maps API, Mapbox API. Those come with license keys. So it's a little more involved if you want to launch something with those libraries. All right, so, okay, so like what can Folium do? We're gonna go over this, but this getting started kind of gives you an idea of what you can do. Look at that, Slippy maps within a notebook. And we're gonna work with this, changing the base map, adding markers, and so forth. Very cool and exciting stuff. All right, so moving forward, again, I'm hoping that part 1 kind of familiarized with the kind of workflow of working in a notebook and working with Python. Within the notebook, each cell represents a process. And the first process in a Python project is always to import a library. So in this case, we're importing Folium, Shift-Enter. You guys are all pros at this now. I get my nice number 1 telling me this is the first thing that I've done in this notebook. And we're going to create our first interactive map using the Folium .map argument command. And at the very basic level, we need to feed it certain things. We need to give it a location for the center of the map. And you give it a latitude and a longitude. We need to give it a zoom start. There might be a default actually. Maybe you don't actually need this, but you know, if you're working locally or if you're working globally, you want to know, you want to set this to be 0 for the entire planet, 16, you might go further up to like 18 or so to be very zoomed in. Control scale just adds a scale to the map. Chain all those together and it produces a map. Let's have a look. That's pretty cool. Within the notebook with just these arguments, I have a fully interactive map. It's slippery, it's beautiful, it's got labels. It can zoom in and out with a scroll wheel. I can go the entire planet. I can zoom in. Simply amazing that we have all this information. Go to Westwood, our abandoned campus here. Oh, the memories. If we were doing this in person, you would all be right there in the visualization portal in Math Sciences where my office is. Okay. So all this is available to you by importing the Folium library and creating a map. Okay, and again, you can play with this. We can change this to any number here that's within the range of latitude and longitude coordinates. So I changed the longitude to 135, and this is my city that I was born in Osaka. And so you get the idea. Changing certain parameters here will change what you see on the map. Let me change this back. Oh, Control Z works to undo what you did. And run this again, and I'm back in LA. All right. What else can we do with this? We can change the base map, which is always a favorite exercise to do. There are different base maps available to you. You can look at the documentation. The default is the OpenStreetMap that we were just looking at. But we can have, for example, a different map, like a dark matter map. So that creates a darker map. And in this case, I'm defining it through tiles. Instead of base map, they use the word tiles. There's a long history behind why that is. Tiles, and I'm defining it to be the Cardo tile set for dark matter. It has to be exactly spelled out like that for this to work. And since we're using somebody else's tiles, we have to give attribution to it. So this is required to give attribution to the data source that we're using, which is Cardo right there, Cardo. When I run this cell, it completely changes the look and feel of our map. So now we have a dark map. Why would we want to use a dark map or a light map or light gray map? It's typically so that it's kind of a visual hierarchy thing. We don't want the attention of the user to be on the base map. We want it to be on the data. So by having a kind of faded out background base map, it allows our data to pop out. Okay. Vector layers. So now we're going to talk about adding data on our nice leaflet map. Vector layers are things like points, kind of the 3 key vector layers in GIS, points, lines, and polygons. Vector layers in leaflet is defined as markers for, clickable markers. We've seen them all. Google Maps kind of started it with the clickable markers and the pop-up window within the marker, the info window as it's called. But markers in essence are single sets of coordinates. One latitude, one longitude produces one marker. A line is a combination of vertices. So it's multiple markers connected becomes a line. A polygon simply closes that loop. And it's 3 or more points connected in the end to the first one. And then we can create circles. let's work with circle marker for this segment of our workshop. Before we do that, let me just quickly go to the help.documentation on vector layers for Folium. Again, these are the different parameters that you can feed. Where's the location of the circle? Do you want a pop-up? Do you want a tooltip? What's the radius of it? What's the color of it? And so forth. So let's work with circle marker. So create a variable for a circle. And this is the syntax for it. I'm creating my own variable, my circle, and I'm feeding it a folium dot circle. And I'm giving it a radius, and this radius is in meters. I'm giving it a location. So I'm putting it in the center of our map, 34, -118. I'm giving it a color. I'm giving it a fill. And once I define this circle and put it into my circle, I can add it to the map by doing my circle dot add to map. And then I'm going to output the map with the map command. And I run this, and notice we have our nice dark background. It makes that circle really pop out. And I can zoom into the circle, as you can see here. Now, I set the radius to be 10,000. This is in meters. So this is 10,000 meters from 34, -118. You can kind of start to think about the possibilities of this, like creating buffers around schools or hospitals. You can create walking distances by creating these buffers and so forth. If you have a CSV with a set of points and then create a circle around them, the possibilities are endless. All right. But we're not here to create a single circle in the middle of our map, as cool as that was. We're here to create a circle based on data that we have. So let's reset that map. So I'm going to reset the map by redefining map and just giving it the same parameters as before. Because right now the map has a circle in it. I want to get rid of that circle because we're going to now map our LA Times data. So I reset the map. And I'm going to add the data to the interactive map. All right, so this is a new notebook. It doesn't know what we did in the first part of that workshop because it's a different notebook altogether. If I had chosen to use the same notebook, we can go back and use the same variables that we were using earlier. But since this is a new notebook, we have to start the process again. So I'm going to import pandas one more time. I'm going to redefine the LA Times again and get the places total CSV. And I'm going to output the data right here. Same process as we did before. Okay, 82,880 rows. Let's filter this out to something more manageable. Same process as we did before. What I'm going to do is find the data for the most recent date. So let's sort it by date. LA Times, sort by date. LA Times, remember index location, get the last value of the date and output that last date. It's July 20th. Again, the same thing we did in previous workshop. And we're going to use last date in our query here to, actually, this shouldn't say LA Times today, huh? It's yesterday, actually. But that's okay. I named it LA Times today, so I would not change this because it's going to be reflected in the code to come. But LA Times today is equal to the LA Times 82,000 record data set queried out where date is only equal to July 20th and county is equal to Los Angeles. So I'm combining, let's find out data just for LA County in the last date. So it's kind of a shortcut of all the things that we did in the past, in the first workshop, in one little cell here. So now we have LA Times data, LA Times today data for Los Angeles, 330 rows is what we're going to be working with. Okay. Notice that I'm not cleaning up this data like I did in the first workshop. But based on experimentation with this particular subset of data, I know that I didn't have to as of yesterday. So let's hope that the new data they put in last night doesn't affect this code. All right, moving forward, let's check the data and produce a simple panda plot. I haven't covered this, but you can actually name the data set and do a plot and just define X, Y, and kind, meaning what kind of plot do you want, and scatter. Again, many different ways for you to visualize data. This is yet another one. It's a quick and easy output of the information. Give it a little second here. And maybe it doesn't work. Matplotlib, okay. So it looks like it didn't import matplotlib. I need to import. Let me just try something else. Yeah, okay, so my bad. You need to import matplotlib, which is the plotting library for this particular plot. This step is not that important. It's just a check to make sure that my 330 records have the right kind of data that I'm looking at. So before I even make a map, I just want to check and see what it looks like on a plot. Sure enough, that looks like LA County, doesn't it? There's downtown LA, here's the coast, our islands, Catalina. So this confirms to me, again, this is an optional step, just confirms to me that the data looks good. Okay, now what we're gonna do is something a little bit more advanced. We haven't really talked about loops, but this is something that is very typically done when you get data in a notebook. And data is typically a bunch of rows in a table, and you want to loop through that table in order to do something with each one of those records. In Python, there is code to run a loop on a given data set. And this is the syntax for it. There's different ways to do loops in Python, but this is probably the easiest way to do a loop on a data set that you have imported, a CSV data set. And the syntax is for index, comma. Index represents where you are in that loop. It starts with 0, and it goes to the number of records in your data set. Row indicates that particular row that you're working with within the loop. And what data set are we iterating? We have our LA Times underscore today, which I just defined. And the syntax to iterate through every row is dot iterate rows parentheses. So this is the syntax to loop through our data. Within this loop, so just to kind of make a point, if I loop through this data set, and notice when I hit enter, the next line is indented. Let me just show you the line numbers here. The next line is indented, and it tells me that whatever code I write next is part of this for loop because it's indented. And here I can print each row, for example. And what this does is it'll go through the entire data set, which is 330 rows. And what I'm doing here for this loop is I'm printing every row, basically. So it gives me 330 sets of data in this output. So this is essentially how a for loop on a data set works in Python. Let me delete that because we're doing something more fancy here inside this for loop. Here's my for loop. Here's the content that's indented. Show you the line numbers. And the first thing I do within this for loop is I'm going to define a set of variables within the loop. I'm going to say that the latitude is the Y column. So I'm saying row, square paren, Y. The longitude is the row X. Being a little fancy with the label, I'm concatenating multiple fields here. I'm concatenating confirmed cases. So the row for confirmed cases, the column for confirmed cases in that row. I'm adding some text in between, and I'm adding the name of the place. and I'm putting this concatenated thing within one variable called label. The size of our circles is based on confirmed cases. So now I have 4 variables that I've created within this loop. This is going to be created 330 times separately for each record. And the next part of this, remember our circle we created earlier? We're putting it inside the for loop. So here's a circle, it's a folium circle. What's the radius size? Oh, I defined it here. Confirm cases for size. Location, latitude, longitude. What is lat? It's defined here as the y in my row. Lon is defined here as the x in my row. Tooltip, this is cool. Show you in a second, is the label. Same color, the fill is true. And we're gonna add this circle to the map. So now I run this. And when it's done, nothing happens because I'm not outputting anything yet. And now in the next cell, let's show the map one more time. So now our map has circles on it and not just one in the center of the map. Now this is a database-driven interactive leaflet map. And when you hover over this, the tooltip appears. Remember that concatenated label field we defined earlier? That is this tooltip. So this map becomes very powerful, very informative. We can zoom in all the way down to the neighborhood level and find out what's going on at different scales. And when I hover over each circle, it lets me know information about each neighborhood based on the data that's been driven by our import from the LA Times. Okay. Let me pause for a second here and see if there's any issues or questions going on. Ben, is there something I should address?
Yes, so if you keep missing data, will missing data be reflected in the mapping?
If we keep all missing data, that's a good question. There's a possibility that it will, there's a possibility that it won't. And you will know when it is a problem because the map won't produce what you think it will produce. In fact, it might break at a midpoint where the data just doesn't adhere to what you tell it to do. So you might only get like one circle on the map, and in which case you have to investigate. Oh, I wonder what happened to the second circle. And then you look at the data and you might find bad data, missing data. And this is how you kind of reiterate through your process, through your code, clean up the data. The data that gets imported tomorrow may not work with this code because the LA Times might change something in their metadata and the way their data is brought in. And that can cause things not to work. So yes, it's critical to look at the information as it's coming in. Let's see, anything else? How to toggle line numbers? Yeah, there's a, well, the quick shortcut is to highlight a cell and just type in the letter L, and it toggles line numbers. And that's just a shortcut key. But in the notebook itself, as Benjamin noted, there's in the view menu, there's a way to toggle line numbers. Okay. Is there any other? I know we're over time. We're almost done, but let me just wrap this up then. All right. So I'm not going to go over line by line this next part of it. This is just something extra on how to combine kind of some more advanced features within our interactive map. And we're going to use a charting library. We used Plotly earlier. We're going to use Altair this time. Why Altair? Just so happens that Folium supports Altair and not Plotly. So again, it's driven by the needs of different libraries that we use that work better with other libraries. So importing Altair and resetting our map. And then I'm going to do something here that's a little bit more advanced, which is creating a function. Again, I'm not going to go over functions because that could be an entire workshop on its own. But let me just give you the gist of what's happening here. Functions in Python are created with a DEF. So you start a function by DEF. You name it whatever you want it to name. So I'm creating a function called createCircle. And you give it a subset of parameters you want to feed it. So I say createCircle needs a latitude, a longitude, a size, a place, and a label. So this is my own function. And within the function, I'm creating a bar chart. Again, I won't go over this in detail, but this is the code for an Altair bar chart similar to the ones that we've been using. I'm querying the LA Times. There's a Y and an X. In this case, this is a chart, so it's date and confirmed cases. Give it a color, tooltip. We're putting this chart into a folium feature is what it's called. And I'm naming it Vega because that's what that folium feature within folium is called. I create a circle, kind of like in our for loop. And let me see, I'm running out of real estate here. I'm creating a pop-up, a folium pop-up. I'm adding the pop-up to my Vega feature. I know it's complicated. And I'm adding that pop-up, I'm adding to the circle, multiple things happening here. And I'm finally adding that circle to the map. Long story short, what this function does, creates a bar chart, creates a circle, creates a pop-up, puts the bar chart in the pop-up, and assigns the pop-up to the circle. So a lot is going on, I admit, in this function. Once I run this function, it doesn't do anything. A function in Python or JavaScript or any programming language is dormant until called upon. So for now, it's a function, it's defined, it doesn't do anything until we call for it to create a circle for us. Here's our for loop. Our earlier for loop had a lot of code inside of it. This for loop simply says, defines the label, the fancy label, and it calls our function. Create circle, it feeds the values that the function needs to operate. It needs a latitude, a longitude, a number of confirmed cases, and the name of the place and a label. So I'll run this for loop. This is pretty computer intensive because it's creating a chart for all 330 rows in our data set. And there are different charts per location. So you'll notice that the star kind of hovered there for a little longer than you're used to. And now I run to show the map again. And, okay. And there we go. It looks the same. Hover over works the same way as well. But when I click on any one of these hover overs, you'll notice that now it includes a bar chart that is specific to the place that we clicked. So this is West Vernon. I can zoom in, find out what's going on in Westwood. Remember, we charted this earlier with Plotly. At the high, it's 200 cases. And I can chart different areas here. Although the bar chart looks similar to Westwood, the scale is entirely different, 4,000 cases in East LA. Okay, that's pretty cool, isn't it? And the last part of it is that you can save this as an HTML file. And running this will basically create a single HTML file that you can then, you know, import into WordPress or some other web environment and run it. So let me show you what that looks like. Let me just get out of here. There's the index.html file that was created just seconds ago. It's pretty large, 7 megabytes. But if I run it on a browser, it recreates that work that we just did. And hopefully we can see our final result here. Okay, let me let that run for a while. Okay. In the meantime, let me see if I can answer any questions. I like wow. I thought so too. What is the fill in the circle function for? Yes, the fill can be true or false. So if the fill is false, it becomes an empty circle and it just has the outline, which makes it a lot harder to click, because then you have to click on the exact kind of perimeter of the circle. So by setting fill to true, it allows it to be filled. And I can click anywhere within the circle to enable that. Let's see if that map shows up now. So now we have this map full screen. We can zoom in, hover over, click, produces a chart, click, produces a chart. So this is incredibly, incredibly powerful, meaningful. And remember, if you run this notebook tomorrow, the chart will look slightly different because it will be today's data tomorrow. And that's the power of putting all this process into a script that can be run at any given time to produce new sets of data. Okay, so that pretty much wraps it up. I'm here for the next 10 more minutes, 10, 15 minutes to answer questions. How do you get the, before I answer these questions, I just wanted to thank everybody here for coming out and participating. I really appreciate it. If you could, I'll send out an email too. There's a survey. I'll send out an email later today. I really appreciate it if you could fill out a survey for the workshop. And especially there's a question about how this remote session works for you. We're always looking for feedback from you guys. How can we make this session better? I know for sure I can ask the gardener not to show up during my workshop. Really apologize for that. But again, thank you all for coming out, and please look out for that survey coming out your way. And again, feel free to unmute yourself if you want to talk to me, ask some questions through the mic, or you can put it in the chat window. I'm happy to answer questions. Thank you all.